Now, we are going to give some generalities about the dependability approach and begin to introduce the related fundamental primary approaches. Remember that the MOOC is divided into 4 parts. The first one is devoted to the general presentation, basic concepts, and approaches. The second one introduces the quantitative analyses. The third one deals with the Boolean approaches. And the fourth one handles large and complex systems and draws conclusions and challenges. Now we undertake the part 3 of the Unit 1. And, more precisely, we begin with the first presentation related to this topic. It is devoted to the description of the steps, objectives, and associated tools related to dependability studies. Note that, more details can be found in the Chapter 3 of the reference book. Then, let us look at the steps of a dependability study. Of course, the first step is to accurately define the system as well as the objectives of the study which is undertaken. This is followed by the analysis of the functioning of the system under study. Achieving this step is an essential preliminary condition before proceeding to the dysfunctional analysis. It is of common sense to understand how a system works properly before trying to identify how it can fail. It is of utmost importance that both functional and dysfunctional analyses be performed from a systemic point of view. The dysfunctional analysis comprise itself several steps, of which the first of them is the risk identification. Note that this step should be included in subcontracted studies. The originator is not supposed, indeed, to have identified all the risks by himself. Otherwise, it would be useless for him to subcontract the study. It may be also the opportunity to consolidate the scope of work. Then comes the modeling of the system with regards to the above risks. This comprised the selection of the relevant data needed both from operational and reliability point of views. This allows to proceed to qualitative analyses. And then, to quantitative analyses. This results in modeling and calculations, which in combination with specialists from the field, allow to proceed to comparisons between various designs, to take decisions and to draw relevant conclusions. This both with regards to reliability, availability, maintainability, and safety. In the case that the objectives are not reached, then the project has to be improved and the process is reiterated again. When the analysis is successful, it provides various results like specifications, tests, and preventive maintenance scheduling or spare parts policy needed to reach the objectives. Beyond reliability and availability, properly speaking, this also provides results about spurious failure frequency and main contributors. And, when dealing with functional safety, the probability of failure on demand or the probability of failure per hour can also be obtained. As previously said, defining the system and its objectives is the first step. Actually, this is not as easy as that. Then the first difficulty is to be sure to have properly identified what to do. In order to define the project objectives, many documents have to be gathered and cautiously analyzed and understood. For example, if the project is related to a safety instrumented function, the safety requirements in terms of risk reduction factor and the safety integrity level have to be stated. Then come the technical definition of the system to be studied. For example, for the safety system implementing the above safety function. This encompasses the procedures and the various diagrams related to installation, startup, process flow, process and instrumentation, and safety logograms. The philosophy of operations related to maintenance, periodic tests, or compensatory measures is also needed. Among the documents, the procedure and intervention means in case of accident have also to be considered. And this, with a particular mention to the environment damages. Among the 55 to 60 past years, a whole corpus of methods and tools has been developed to deal with the dependability analyses. And this with regards both to qualitative and quantitative points of views. The basic models include the functional and preliminary risk analyses as well as the failure mode and effect analyze or the hazard and operability studies. Those basic models are very effective to understand how the system works and help to identify the various risks. They only allow to analyze single failures, but they provide analyses at high level which can be sufficient for simple systems. Then we find the static systemic models, which comprise mainly the reliability block diagrams and the fault tree analysis. They provide a way to analyze the systems from structural point of view and allow to take failure combinations into account. Their analytical Boolean background is also the basis for probabilistic computations. Even being static, they can be used to some extent to perform time-dependent calculations. And at last, the pure dynamic models like sequential approaches, Markovian models, and Petri nets come to make up the lacks of the previous approaches. They allow in-depth dynamic analyses as well as behavioral modeling of the systems under study. For large system, the analytical way of probabilistic calculation have to leave the place to the Monte Carlo simulation.